Okay, great. Let's see. Our second speaker today, this afternoon session, is Alberto Leon-Garcia. He'll be talking about the introduction to Savvy Research, SAVI Research Network and Testbed. See, Professor Garcia is Distinguished Professor in Electrical Engineering at the University of Toronto. I think we all know him most famously for his book on probability theory and random processes. And I think there are scores and legions of graduate students to thank you for that book so we could pass our screening and qualifying exams. But on a more serious note, he's a fellow of IEEE for the contributions to multiplexing and switching of integrated services traffic. He's a fellow of the Engineering Institute of Canada. He received the 2006 Thomas Edie Medal from the Royal Society of Canada and the 2010 IEEE Canada AGL McNaughton Gold Medal for his contributions in the area of communications. He holds a Canadian Research Chair in Autonomic Service Architecture, and like I mentioned, he's the author of the leading textbook in probability theory and random processes. So please welcome Professor Garcia.
Thank you. Thank you. Can you hear me? Okay. You know, we all reach a point in our life where you're trying to figure out, where did I go wrong? And in hearing Andy's talk earlier, I got an epiphany, which is that I dropped out too soon, too early. You see, what happened was I came to USC in 1968, right after my junior year in high school, on an NSF summer science program, and I got a scholarship offer. So I never went back to high school, and so I don't have a high school degree. So I did get bachelor's, master's, and PhD at USC, but apparently that doesn't count in terms of success in the big time. When I got invited to come and talk, I immediately said yes. And it was for one particular reason, which was to thank my profs. Okay, I was here from 68 to 77. I finished my PhD in 77. I took courses from most of the Magnificent Seven. I had never heard that expression until today. And they were all in my qualifying exam and PhD defense and so forth. So thank you. Thank you. I wanted also to talk to the students who are over in the back and tell them a little bit about what I learned at USC. It was, I think, and it's been apparent this morning, that it's a very rigorous training in terms of system design. I took 464, I think it was my freshman, it might have been my sophomore year. Somebody sort of challenged me to take this course and said, okay, sure. And I never looked back. I loved it. So 464, 562, Professor Schultz, I still have your notes. 564, communication theory or systems, I don't remember. Theory, and then information theory and coding. And the thing was that when you took your qualifying exam, you see, the challenge was that you didn't know who was going to write the question. And there were as many versions of 564 as there were professors in the group. So what you did is you sat in all of them, sat in all their courses, and that way you knew you could answer the questions no matter what. Now it turned out that I had 2 summer jobs here after my junior year and senior year at Bell Labs. One, I got introduced to traffic theory and queuing theory, and the other one, switch design. And that sort of, once I graduated, it took me in a different direction. So I wasn't able to work in comm theory, if you will, as such. But what I learned was from probability and random processes with how to design systems in the presence of randomness. From comm theory and systems, the notion of optimality in receiver design. From information theory and coding, the fact that there's fundamental limits. okay, looking for those bounds that you can't beat, and that saves you a lot of time in terms of trying to improve things that can't be improved. The other was how to become a teacher. I've gone on and had a very joyful career, if you will, teaching. And I think I learned a lot of these things. Professor Weber, when students complain about the homework I assign in grad courses, I always use you as an example. That's nothing. When I took 564 from him, he was using his book, he was using Van Trees, and he was using Wozencraft and Jacobs. And we got problems from all of these. I remember spending entire weekends just solving problems. But you know what? I was really happy doing that, and that's what I tell my students. You should be happy working. The other was many of the professors, maybe all of the professors, had manuscripts. Okay, and Professor Schultz, you've got so many manuscripts, and the one on random process, there was one on coding, and I don't remember if I know I have the notes. I don't remember if you had a manuscript on radar, but you tended to write up notes, and what you learned, what you picked up is that there's this part of the profession that you're trying to make sense out of all of the material and put it together and to teach it. So I learned that, and for you guys in the back, listen. Okay, so as I said, I started, if you will, physical layer, and now when people ask me, I say I'm working layer 8. Okay, but I progressively ran from layer 2, medium access control, to networks, and now I'm working on something I call application platforms. This expression was coined by Tim O'Reilly, who's one of the Silicon Valley gurus in terms of internet. And he was trying to make sense in terms of who would win. He had a series of articles in terms of Apple, Google, or Microsoft. Okay, and so he looks at the notion of an application platform as everything that's involved in the delivery of the applications. And then he goes into analysis as to where the strengths are and so forth. But the question, and if you look what's driving investment in ICT, okay, it's apps, okay? And so, but the attraction of apps is the fact that you can raise revenue, and that raises the interest of investing in infrastructure. If you don't have that chain, it's not gonna happen, okay? Now, the thing that bothers me about this kind of setting is that what you have is different semi-walled gardens that are evolving separately, okay? And the option of going back and forth, you're kind of stuck. You pick one system, you pick Apple, and your life is a lot simpler if you just use Apple devices. You try to diversify, you're going to have trouble. And so the question I was asking was, is it possible to create an open applications marketplace? Okay? So so that led me to start this center called SAVI. SAVI stands for Smart Applications on Virtual Infrastructures. And it's in Canada, our NSF is called NSERC. And it's an NSERC strategic network. And what we're trying to do is build a testbed to answer the kind of questions that were being posed in the previous talk, okay? Experimentally. And I recruited a team of professors, all of whom have built something, okay? And our task is to build a testbed within 3 years to start answering some of these questions. Okay. So what's the SAVI challenge that we're looking at? We're looking at this vision of what I call the application platform. And what we want to do is support an open applications and content marketplace. Okay? The idea is basically that entrepreneurs can come up with ideas, new business ideas, that would be implemented using computing and communications infrastructure, i.e. internet and cloud computing. And that the tools would be readily available for converting the business ideas into workflows, which become implemented in terms of software, and for which the tools are available, the dynamic tools are available for deploying them readily and growing them and shrinking them as appropriate, which is what cloud computing does. And so what you can look at this environment, if you look at it at big scale, is large numbers, many, many small companies, some big dominant companies, and a lot of churn. Okay, if you look at statistics in terms of downloading, okay, they're very bursty. There's short periods of time where there's a lot of interest in particular content, goes away, then something else. Same thing's going to happen with applications. So what you want is an infrastructure environment that can dynamically adapt quickly to provide what you need at a given point in time. And so the requirements come down to resource management. Okay, it's the same old stuff we've been talking about in computer networks and multiplexing, but you need to do it in a very agile and responsive way. Okay, and so that's one aspect. The others were already referred to: scalability, reliability, and so forth in the previous talk. Another one is multiple ownership. If you want this openness, you want to have the ability of federating, I get this resource from you, I get that resource from you, I get this piece of software that I'm going to run on that from you. Okay, so federation, the ability to interconnect and use multiple sources of resources and services. So the challenge we're looking at is the design of this infrastructure for application platforms, a very modest goal. So here's a picture in terms of the cloud. We call this an extended cloud. When you talk about cloud today, you think of an end device, either a computer, more likely a smartphone, going to the cloud and mediated by the internet. Okay, now one of the things that I've worked on a lot is with telecom providers and equipment vendors over the years, and I think that they need to be asking the question of where's my future? Okay, and so I'm asking the question on their behalf, and I'm saying there's an evolution of a smart edge. What I mean by a smart edge is a set of resources that's relatively close to the user, okay, because of responsiveness reasons, because of transfer of large volumes of information. We heard about video distribution earlier today. So there's a need to have some infrastructure close to the users. Where exactly that is, not clear. Roughly where the service providers today. Now, I think that the advantages that cloud computing provides in large data centers, virtual machines, being able to dynamically manage these to meet demand, I think that can be done in the edge as well. No reason why not. Except that I think that the resources at the edge has to be more diverse. Okay, and let's look forward as to why I think that. If you look at the question of what the access is going to be, the default access is going to be mobile and wireless in the future. The demand is going to be for very high bandwidth that we've already spoken about today. The no-brainer way of providing more bandwidth is go to smaller cells. Okay, but you have to do this in an economic way. Okay, so you need inexpensive access points. And dense antennas, dense cells. Okay, so you have to start exploring more economic ways of providing that kind of access. So given the scope of what we had, I decided we can only have a small effort in this. And what we did was we took it radio over fiber. So let's consider the range of possibilities of taking radio over fiber into the smart edge. Okay? And in the spirit of everything else that we're doing, we want to use virtualization and programmability. So that works very nicely in the sense that now you have a central point of control in terms of the power, which access points are turned on. You can get energy proportionality in the access. But if you want to implement that, you're not going to use computer blades. But you can use FPGAs. So part of what we're looking at is virtualizing FPGA resources in the edge. So we're looking at a more heterogeneous set of resources in the smart edge, but managed using cloud computing principles. Okay? So then the projects that we have in Savvy, okay, it's looking at issues that are central to application platforms, but from a network and service provider perspective. The One of the things, I ran a startup from 2000 to 2003 building a very big optical multi-service switch. And I learned a couple of things in terms of trying to sell the switch to MCI, AT&T, and all of those guys. And that was that the future in terms of where the revenues were going to come was very hazy. Okay, the mobile access as a source of revenue for the next little while was clear, but the voice as a big source of revenue, it was clear that was going away. How you monetize content, not clear. So in order for this infrastructure that we're building to answer useful questions, I recruited a team of application developers. Okay, professors that work on big data, professors that work on mobile services, professors that work on video. Okay, and their task is not to develop applications, but to look at classes of applications and try to anticipate this environment where you have very high bandwidth available to you and say, what kind of applications are you going to need in that environment so that we can test it ahead of time. The question of the service provider smart edge, now implicit in this question is in normal cloud computing now you've got resources in the end system and in the cloud. Now the question here is what role does this smart edge play in terms of mediating and supporting applications, okay? You cannot get the economies of scale in the smart edge that you can in the very large data centers. But on the other hand, you can get agility, you can get responsiveness. So that part has to be a lot more agile, if you will. So we're investigating what we call a two-tier cloud, which is this over here, which we currently have, and investigating how applications are apportioned between these two dynamically according to the demand. We're investigating, as I said, wireless optical access, and we're trying to virtualize that. And what we have to do is develop the control and management to support this environment. Okay, so how much time do I have? Okay, so use cases. Okay, so an environment, think of an environment of a stadium. Okay, and everybody's got their smartphone or whatever. Okay, it all's got HD video. It could be one of the USC games, right? USC, UCLA, or USC, Notre Dame. Okay, and everybody's streaming their stuff. Okay, and we made up this application we call Kaleidoscope, which involves in real time gathering letting users upload their videos. And quickly thereafter allowing users to compose, extracting that video according to a certain perspective, a certain interest, according to where the friends are, okay? And so what you have in this environment is one in which you need very high capacity in terms of computing, in terms of wireless, in terms of the smart edge, okay? And then the game's over. Right, so what happens? People start driving up Hoover, I guess, and Jefferson and whatever. And in most places, there's a whole bar area nearby, right? So they move to the bar. And now people want their kaleidoscope in big screens in whatever their favorite watering hole is, right? So as this is happening, all of the resources are being reallocated dynamically on demand. Okay. I think my time is up. Let me just, I'll show you one picture. This is not just chartware. So I'll end with this. We're using OpenStack. We're using OpenFlow to try to create a software-defined network environment. We have a 3-year plan for developing this management software for the testbed. We just completed our first year, and this picture is of our workshop where we provided the participants with tools to be able to get both computing and FPGA resources and implement some simple applications, okay, in a short period of time. Okay, so I'll leave it at that.